SP15 Forces and Matter. You need to explain using springs and other elastic objects that stretching, bending or compressing an object requires more than one force. Right, if you're going to stretch an object, you need one force at one end and one force at the other end, both pulling away from each other. If you're going to bend an object, you're going to need two forces on the end pushing the same way, and then one force in the middle pushing the opposite way. To compress something, which just basically means squash, you need one force on one end pushing inwards and another force on the other end also pushing inwards. Describe the difference between elastic and inelastic distortion. So elastic distortion means returns to the original shape when the forces are removed, and inelastic distortion means does not return to the original shape when forces are removed. So it would keep the new shape. So you literally get marks for saying those things there. Recall and use the equation for linear elastic distortion. So F equals Kx. So that's force equals the spring constant times by the extension of the spring. You often rearrange it to get the spring constant. You just do the force that you've put on the spring divided by how much the spring extended by. Use the equation to calculate work done. Well, remember, work done is energy transferred. Both units are in joules. So you'll notice the equation here says energy rather than work done, but it's the same thing. So to work out how much work or energy you've transferred on a spring by stretching it, you do a half times by the spring constant times by the extension squared. Describe the difference between linear and non-linear relationships between force and extension. So as I say to my students, linear basically means the straight part of the line, and non-linear is a curve. So when you're putting a force onto a spring, it'll extend. Now at first it will extend proportionally. So the force is proportional to the extension, and that's, you can tell because it's linear, in other words a straight line. Now that's what we'll call the elastic distortion. So if you were to take the force off, it would go back to its original shape. However, once you go past a certain point called the elastic limit, that's the end of the elastic distortion, and it's the start of inelastic distortion. In other words, if you were to take the force back off, the spring would never go back to its original length. You'll always end up with this extra little bit of extension. Okay? So it did not return to its original shape. It's been permanently turned into a new shape. Right, and the last bit is core practical, so this is important. This could be the 6th marker. Investigate the extension and work done when applying forces to a spring. Right, so tell the examiner you'd measure the original length of the spring when there's no weight on. So get a clamp stand, right? Get a clamp on the stand and hang your spring on it. Now you'd have to put a ruler next to it and get the original length of that spring when there's nothing hanging on the end. Then you would hang 1 Newton of weight onto the spring, and obviously the spring's going to start pulling down. So use your ruler to measure that new length. Then what you do, so for your 3rd mark, measure the new length. Then for your 4th mark, calculate the extension. So tell the examiner, get your new length and take away the original length. So get that new length there. I don't know, that might be 20 centimetres, and the original length might have only been 10 centimetres. Then for your 5th mark, you say repeat steps 2 to 4 until you've got 6 results. Why 6 results? So you can spot a pattern. So hang 2 newtons on, then 3 newtons, then 4 newtons, then 5 newtons. You know what I mean? The spring will get longer and longer and longer. Then for your 6th mark, tell the examiner you're going to use K equals F over X. So just make sure you put that in just for an extra mark. And you'll be able to calculate the spring constant K. Or they might be specific and say they want you to plot a graph. So you'd have to plot a force against extension graph, just like this over here. And you can calculate the gradient. If you're going to put force up the side and extension along the bottom, that's the y-axis divided by the x-axis. You're basically doing F over X, which means you're going to get K. So the gradient will be K. So I'll calculate the gradient once you've plotted your force extension graph. Just in case you haven't got the 6 marks already, or they're very specific and they say they want you to get the work done, make sure you put the work done equation in. Tell them that you're going to calculate the work done, so half k x squared, and then even tell them repeat for different springs and compare. Now don't just say repeat, you've got to say repeat and compare. So if we look over here, if you were to get a steep slope on your force extension graph, that means the spring's stiff. In other words, you needed a greater force to create an extension. And if you get a flatter slope, that means it's not as stiff. So in other words, less force is needed to create an extension. So look, I don't know what that extension is there, just say that extension was 10. This slope only needed a little force to create the 10, whereas this spring with a big slope needed a lot more force to get the same extension. Now I have seen this as well, you are supposed to know what would a rubber band look like, so just remember that shape, it goes up like that. If they ask you to explain it, well remember if it's steep, here, that means it's stiff, so the rubber band is stiff at first, then it goes flatter, so that means it's not as stiff, and then it goes stiff again. So if you've ever pulled a rubber band, that's right. It can be a little bit stiff to get it stretching, then it goes all easy to pull, and then towards the end, if you keep stretching it, it goes quite hard to pull it. And a spring, well, that was the same as before. It's directly proportional at first, so it's linear. So directly proportional would mean it goes through the origin, 0, 0, and it's linear. So in other words, if you were to double the force, that would double the extension. Then up until the elastic limit, mind, and then you're going to get your permanent extension, your inelastic distortion. So best of luck with your exams, and good luck for your future. Work hard, be nice, and bye for now.